Snow, maybe? Questions on those? That's just stuff from last week. This one, it says the order of the magnitude of Earth's mass is 10 to the 27 grams. The order of magnitude of the sun's mass is about 10 to the 33 grams. I find that interesting that they know how much the sun weighs, about. How do you think they calculate that? Anybody have any ideas? Put it on a scale? I'm guessing they kind of know what it's made up of, and they might know the weight of whatever it's made up of per volume. I don't know. Maybe. And the size of it they know. So, I don't know. Okay. Definition of zero, you know most of this already. Anything to the zero power is what? Right on. Shall I write always, always, always? Okay. If a base has a negative exponent, then switch from numerator to denominator. And make the exponent positive. Also, vice versa. If it's in the denominator, you put it in the numerator. Okay? All right, we don't need to do all of these, obviously, because we already did some. But let's start with this one right here. Let me make it a little bit bigger. Okay, the first thing you need to do is what? Using the properties that you learned last week, what would be the first thing you would do? Distribute the 2 to the 6, which would be 2 times 6, which would be x to the 12, over x to the 12. If you subtract the exponents, you're going to get x to the 0, and you know that equals what? 1. Do you need to do this middle step? No, because hopefully you know that something divided by itself is 1, but this just kind of proves the way it happens. Okay? Oh, what's math to the 0 power? 1. These don't take very long. Let's just work through them. Hopefully you know how to rewrite this without negative exponents. What would it be? 1 over what? Okay, 1 over 36. Either way, 1 over 6 squared or 1 over 36. Okay, using our properties from last week, what would be the first step in this problem? So I have 2 to the negative 2 and 3 to the negative 2. I don't want any negatives. What should I do? You're really just switching both of them because this one has to go on the top and that one has to go on the bottom. So you just switch them and rewrite them as a positive exponent. Cool? I don't know. This is telling me this. Should you leave your answer like that? It's a bit of a problem. What's the problem? What? They're not the same base, but there's something else that is a problem with that answer. Yes? Right, but what are we doing here? Can you divide by 0? Ever? What's your calculator going to tell you? Because you're asking the calculator to take one thing, number 1, and split it into 0 groups. What? It doesn't make any sense, right? So you can never divide by 0. So you should write something like undefined so that I know that you know I can't divide by 0. All right, turn it over. So this one has a positive exponent. I'm going to leave it where it's at, which is on top, over 1 basically. And this one has a negative, so I'm just going to keep the one on top and move the one with the negative on bottom. Oh, and look what happens. When I subtract exponents, I get this, which is 1. Okay, property from before, 3 to the negative 6. I don't want negative exponents, so I'm going to write it as what? 1 over 3 to the 6. All right, I can't have negative exponents in my answers, so what am I going to do to this one? You put it up on top, so basically it looks like that, and really you just don't write the 1 equals 8 squared, or 64, however you want to put it. Okay? All right, here. If I have the same base and I subtract the exponents, I'm going to get 7 to the negative 2. Yes? 1 over 7 squared. Now, the way we talked about it before, you may just know that, if you have 3 7s here and 5 7s here, you're going to cancel out, and you just have 1 over 7 squared. You may just know that, but just in case. All right, let's finish these. They don't take very long. Simplify the expression. What would be the first thing you should do? Distribute that 3 to each exponent in there. So you have 3 to the third, x to the negative 6, and y to the 6. I don't want a negative exponent. So when part of it is negative, you don't move all of it, you just move that part. Where would you move it? Underneath everything else. X to the 6. See what happened there? It just went underneath everything. Okay? Okay, this one kind of has some stuff going on. So when I get a problem like this, the first thing I would do is move my negative exponents and rewrite it so I can see what's happening. So I still have 4 and 8. That negative 2 is not on the 4, it's not on the y, it's only on that x. That's what gets moved, nothing else. Okay? So y to the 4th stays up there. X to the negative 2 comes down below and becomes x squared. I still have my x, and I still have y to the 6 down here. Yes, we're not done yet. Now once you've moved it, then you have to start saying, what can I simplify? And the very first thing you should look at is those numbers. 4 over 8, can that be reduced? Yes, it's just a fraction, so I'm going to reduce that to 1 over 2. I took care of that. Y to the 4th over y to the 6th. If I subtract 4 minus 6, it's negative 2. Where would I put them? There's more on the bottom, right? So they would go down here, y squared. I took care of the y's. And then x squared times x is how many x's in the bottom? X cubed. So there, that's as far as you can go with that. So I'm just going to make it a little bit prettier. It doesn't matter what order you put those variables in. Okay? All right, almost done. The order of magnitude of the radius of an atom is about 10 to the 5th times as great as the order of magnitude of the radius of a proton, which is 10 to the negative 15. What is the order of magnitude of the radius of an atom? I think this is sort of confusing, even when I read it the first time. So I said to myself, I'm just going to give it different numbers, just for the sake of setting it up. I'm going to say the order of magnitude of a radius of an atom is about 6 times as great as the order of magnitude of the radius of a proton, which is 2. If it's 6 times as great and the proton is 2, how would you find out what the radius of the atom is? What would you do? Divide, wouldn't you? 6 times as great and the proton is 2, you would divide. If that helps you set it up, do that. And then use the real numbers. So I have to do, I'm sorry, I wouldn't divide. Somebody corrected me. Would you divide? No. No. If the order of the magnitude of the radius of an atom is 6 times as great as the order of magnitude of the radius of a proton, and the proton is 2 meters, then I would have to do 6 times 2. Because it's 6 times as great as the proton, right? 6 times as great as the proton. Okay, now I know how to set it up. I'm going to use the actual numbers that they gave me. It just helps me figure out how to set up the problem if I use real working numbers. So it would actually be 10 to the 5th times 10 to the negative 15. 6 times as great as the proton. So that's 10 to the negative 10. Now, you can leave order of magnitude with a negative exponent, but I want you to think about it. We're talking about the radius of an atom. Is an atom super, super, super tiny small?
Yeah.
Well, wouldn't 1 over 10 to the 10 be a super, 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 super tiny small number? Yeah. I just want you to kind of think about that. So, all right? That is it.